This is the Pre-Calc Unit 8 Lesson 3 video. The unit is logarithms or exponential and logarithmic functions, and this lesson deals with the properties of logarithms. If you have a chance, go on. I don't know why this video is hiccuping. I've already re-recorded it a couple times. The app is giving me a little bit of an issue. We'll see how this goes. So if you have a chance, go on Google Classroom and take a look at the warm-up as well as the lesson notes, and I will be working from those two documents, the lesson 3 documents for those. If you don't have an opportunity to print, that's fine. If you don't have any way to print the documents, just grab some notebook paper, especially this lesson more than any other. There's no graphing whatsoever. You just need to be able to write the problems down and work them out. And there's quite a bit of practice here, but it's all just algebraic and logarithmic steps and expressions and that. So you just need notebook paper, which would be sufficient for you. So anyway, let's start with the warm-up. So if for some reason you don't have access to Google Classroom or this document somewhere else, I'm going to talk for just a few more seconds so that you can pause the video and get to work on some of these problems. I am not going to talk through any of these problems. This topic was all covered in lesson 2, and so if you can't already figure out how to do these problems, then go back and check out lesson 2 or contact me with questions about this topic, but I'm not going to talk through these warm-up problems. So what I want everybody to do then, once you've either gotten the sheet pulled up on Google Classroom or you have copied down the problems from here in the video, I want you to pause the video and work out the problems, and then in a couple seconds I'm going to go ahead and just display the answers for each of these problems. So the screen that I displayed a minute ago with the questions on it, I had compacted just so that you could see them all in one screen. I will scroll this up in a second, so you would be best off pausing the video, checking your answers. Take a quick look at the ones that I wrote out, the steps in red. Those are going to be the tricky problems. And then here are the rest of the answers. And as soon as you're done checking your answers, we will go on to take a look at the lesson 3 notes. Today's lesson is about the properties of logarithms, and what you want to keep in mind, first of all, is that a logarithm or a logarithmic expression is an exponent. And so this really ties back to the laws of exponents that we talked about a couple of lessons ago, where if you're multiplying the same base with different exponents, you add the exponents, or if you're dividing, x to the 5th divided by x to the 3rd, you subtract the exponents, 5 minus 3, and so on. So these properties all tie into that. You will not be given any kind of a formula sheet on a test for this, so you need to know these properties. You need to remember them. And what I'm going to do is talk through, in fact, these first 4 examples where it says expand are going to correlate each one to the properties. So for example, And I'm going to talk through this property here using example 1, and I'm going to talk through this property here using example 2, and I'm giving you a little bit of time to process and think. And this property here uses example 3, and I'm also going through all of my colors. How about purple? This property here will be using example 4. So, yeah, I'm making a mess of the menus over here that you can't see. So, in example 1, the idea here is that you're taking, let me start with the directions say expand, and for each of the problems on this page, when the directions say expand, you're actually taking this expression log base 5 of a times b. You're actually taking that expression and you're going to make it bigger. So it's almost, but not quite, it's almost opposite of the idea of simplifying. You're literally, I wish you could see my hand motions here, you're literally pulling apart this logarithmic expression. And so what you want to do is you want to say, look, I am taking the logarithm of a multiplication problem. And if the entire argument of a logarithm is a multiplication problem, then you can take the logarithm of each of the things that are being multiplied and add those logarithms together. So you have to remember to write the base, so log base 5 of a, and you're pulling this apart, so then you're going to do plus log base 5 of b. Now, that's because a and b were being multiplied. But what if you've got a division problem as the argument for your logarithm? So take a look at example 2. Here, I've got the entire argument of the logarithm is a division problem. I'm going to take the log of the numerator and the log of the denominator and subtract them. And it's really very important, the order. It's the log of the numerator minus the log of the denominator. Keep the base of the log, so log base 3 of m, minus log base 3 of n. So compare example 1 and example 2. If the argument of the logarithm is a multiplication problem, you add the log of each thing being multiplied. If the entire argument of a logarithm is a division problem, to expand that, you take the logarithm of the numerator minus the logarithm of the denominator. In this third example, if the argument of the logarithm has an exponent on it, that exponent becomes a coefficient. And so to expand this, it actually isn't going to look a whole lot bigger, but this will be a step as you work toward expanding larger expressions. So you would just take that 4 and you would rewrite it out in front 4 times log base 7 of y. And you're literally moving the 4 from the place of being an exponent to being a coefficient. And then the fourth example here is kind of like, in fact, some textbooks don't separate the concept of the division with the log of a division problem is log minus log from log of a reciprocal fraction, 1 over something. But I like to show this to you separately because the 1 in the numerator can be a little bit tricky. And so it's just easier to learn the result rather than trying to walk yourself through the log of 1 is 0 and then 0 minus a number is a negative number. Anyway, the other thing that I want you to keep in mind here is, wow, I hope you don't see all of that. So remember that ln means log base e. Okay, and so in this case, we're going to still write ln. Don't write log base e. You would never find a mathematician that does that, and I would probably take off points for it on a test. But if you have the log of 1 over a denominator, it's going to be minus same log of just the denominator. And I want you to compare, what I want you to really look closely at is that whatever was in the denominator has a minus sign before the logarithm. Whatever was in the denominator has a minus sign before the logarithm. So a denominator is then written with a negative log. So what I want you to do is kind of telescope back out again and compare example 1 to the first property, example 2 to the second property, example 3 to the third property, and example 4 to the fourth property. Maybe pause the video and stop and think about that for a minute. And then the rest of the problems on this page are going to get increasingly more complex in that I'm going to add steps, add little twists and turns to the problems. So make sure that you understand those first 4 and try to remember, start memorizing them now. There's plenty of practice in this packet, and so as we move ahead, you'll have a lot of opportunity to practice. So let's take a look at example 5. It's a division problem. This example is going to have 2 steps to it. So I'm going to start by writing log, don't forget the base, of the numerator minus log base 3 of the denominator. And before you move on, make sure that that makes sense to you. But the next thing that I want you to do is ask yourself if you see something in this problem, some part of this problem that could be simplified farther. And there should be something poking at your head that says, oh, 3 and 27 have a relationship that is related to exponents and logarithms. So if you were to isolate just log base 3 of 27, you hopefully know that that is equal to 3. And so your answer to this whole problem is 3 minus log base 3 of x. Here I see that I have a multiplication problem as the argument of my logarithm. And when the argument of the logarithm is a multiplication problem, to expand that, I'm going to create an addition problem, logarithm plus logarithm. So log of 6, log base m, yes, you have to write the base m, log base m of 6 plus log base m of m. And again, I'll say, there's a piece of this problem that can be simplified farther. Is there anything that stands out to you that can be simplified farther? Ah, yes. Log base m of m. When you have the base of the logarithm is exactly the same as the argument, then that whole thing is equal to 1. And so the answer to your whole problem is log base m of 6 plus 1. And just keep in mind that only the 6 is the argument of the logarithm. This is like shifting a graph up, and the plus 1 is an outsider. The 1 is not associated with log base m of 6 at all. But your final answer is log base m of 6 plus 1. I find that students who understand this topic really well get stuck on a problem like this. So I want you to make a note to yourself, maybe in the margin or something, that none of the properties above apply to the argument of a logarithm being an addition or a subtraction problem. So if you have the entire argument of a logarithm is an addition or subtraction problem, you can't do anything else. You're done. This problem is over. Make a note that this cannot be expanded farther. And what I want you to think about is that, yes, there's a relationship between a multiplication problem as the argument and a logarithm plus a logarithm. But remember that the logarithm is the exponent. So logarithm plus logarithm is when you're adding exponents. In this case, the logarithm, there's only a singular logarithm, and that the entire argument is an addition problem. So don't think it backwards. You're starting with the addition problem, you can't do anything to that. It's only when you start with a multiplication problem that it becomes log plus log. And number 8, I am going to rewrite the argument of square root of y as a radical, or I mean as an exponent instead of the radical. So I'm going to rewrite this. I'm not done yet. I won't be done yet with this first step. There's going to be more. There's going to be another step. But log base 4 of y, remember that a square root can also be written as the 1/2 exponent of 1/2. And then remember that if you have an exponent that is within the argument of the logarithm, that exponent can be written instead as a coefficient. So this is going to be 1/2 times log base 4 of y. And number 9 is similar. What I'm going to do to start with is rewrite the radical as z to the 1/5 power, 5 because it's the index here. So I've got log base 11 of z to the 1/5 power. And then again, I've got an exponent inside the argument of the logarithm, and so I'm going to write that as a coefficient. So 1/5 times log base 11 of z. Now I'm going to pause for a second, ask you to maybe hit pause on your video screen and just think through the first 9 problems here and make sure every one of them makes sense to you, because the next 3 problems, in fact, I'll move that up a little bit. The next 3 problems get a little bit crazy, and they've got, well, the 11 and 12 have a bunch of steps to them. And so I want you to make sure you're solid on the basic concepts before we start combining them. So a couple minutes ago I said, make sure that you see that if you have a denominator inside the argument of a logarithm, that what's going to be a part of your problem is minus log of that denominator. And so you could write this problem out like this as your first step. I might not do this problem in multiple steps, but you're welcome to do so. But what I want you to think of here is that it's the log of the numerator, log base 7 of xy, minus log base 7 of z. And then you've got log base 7 of xy that can be expanded farther. So anything that can be expanded farther has to be expanded farther. So that's when you know you're done, is if you can't apply any of those properties at the top of this page to your problem to pull it apart even more. So I'm going to take that log base 7 of xy and I'm going to write it as an addition problem. So log base 7 of x plus log base 7 of y minus log base 7 of z. And that's it. That's your final answer. When you see minus log of something, that means that it was a denominator in the original argument. So here, again, notice that you have a denominator, and I think that I forgot to turn off the sound on my devices again. I've got like 4 devices here that I have to remember to check the sound for. My own computer, my work computer, my phone, the iPad. If I forgot to turn the sound off on the iPad, you'd be hearing that too, but that was actually my work computer, and it was one of you guys emailing me. Hi. Anyway, craziness. So you want to kind of develop a relationship here between order of operations and the order that you can do these things. So rather than a formal PEMDAS, what I want you to start to think through is the bigger problem working from the outside in. So instead of starting inside the parentheses, start from the outside. And I will start with taking this exponent and writing it as a coefficient. So my first step is going to be 5 times log base 3 of crazy big fraction. Okay, maybe not such a crazy big fraction, but it's going to feel like it in a minute. Now, what I want you to do is to keep, it keeps blipping like that, and I've got plenty of storage space in my iPad, so I don't know why it's doing that, but I'm afraid I'm going to lose the video. So in a minute, I might just go and save it. What you don't have to do this, but what my thinking is that I'm going to multiply 5 times my answer to everything that I'm going to do inside of these pink parentheses or brackets. So keep the 5. Don't ignore it. Don't forget about it. But mentally set it aside, and I want you to work just on what's inside the pink brackets here. And so start with the fact that you've got this fraction. So I'm going to write the 5 and then times, and then I want you to look at the fraction. So it's log base 3 of 9 minus log base 3 of xy. And here's, you may be thinking to yourself, well, that's not so tricky. Here's the tricky part, and I want you to kind of track with me. You're subtracting the answer to this. And because there's 2 things being multiplied in the denominator, you're going to make this an addition problem, but then you have to distribute the subtraction. Here's what I mean by that. Keep the 5, keep the bracket. Yes, we're going to simplify log base 3 of 9. If you see it, go ahead and do that now. Minus. But then I'm going to do this thing in yellow. So minus parentheses log base 3 of x plus log base 3 of y. And what I want you to do is stop for a second and make sure you understand the relationship between the yellow part of the problem here and the yellow part of the problem here. And that you understand why I have parentheses here and I'm going to need to distribute the subtraction. And when I say I'm going to need to distribute the subtraction, here's what that's going to look like. I'm going to keep that 5, log base 3 of 9, minus, and then distribute a negative 1, so minus log base 3 of x minus log base 3 of y. And again, let me highlight. So all of this was a result of what was in the highlighted parts from the 2 steps above. The next thing that you should notice is that log base 3 of 9 is equal to 2. So keep the 5, 2 minus log base 3 of x minus log base 3 of y. This here became this here. And then the last step, I have to distribute the 5. And so I end up with 5 times 2 is 10 minus 5 log base 3 of x minus 5 log base 3 of y. Now what I'd like for you to notice is that you had both the x and the y in the denominator of the original argument, and both the x and the y have a minus sign before the log. The other thing that I can point out to you is that there were 3 things in the original fraction. So I have the, you know what, let me erase here in the denominator. So in the original fraction, I hope you're not seeing what I'm seeing because that concerns me. So in the original fraction, I had these 3 things that I'm focused on. The 9, the x, and I'm running out of colors. Let's just do, no, I don't want to do that. How about hot pink? The x and the y. And then in my answer, the 9 was a numerator, and so the 9 is going to correspond to this 10, and the x was a denominator, so the x is going to correspond to the minus 5 log base 3 of x, and the y was also a denominator, and so the y is, or the denominator there is going to correspond to the minus 5 log base 3 of y. There's other ways that you can show the steps to this problem, and you don't really need to show that many steps to actually work your way down to this final answer. You may not even need to show multiple steps. You may be able to get from the original given problem to the answer in 1 step. Just make sure that you pull that 5 exponent out front and that you simplify the log base 3 of 9. Now in number 12, I have the logarithm of a multiplication problem. So here, I can start this problem by saying log base 2 of 7 plus log base 2 of, and it's the radical that's going to be slightly problematic. The log base 2 of 7 you're not going to be able to do anything with. So in your final answer, I've got, I think, 5 different steps on my, written out on my answer key draft. The first term of your final answer is going to be log base 2 of 7. That's all you can do with that term. But what I'm going to do, and I keep writing it, don't fail to write it just because you're not using it yet. But what I want you to do is then rewrite just the argument that's the radical. Instead of with a radical, write that with a 1/2 exponent. So log base 2 of 8x to the 1/2 power. And you need the parentheses because the parentheses show that the entire thing, 8x, was inside the radical. But that still doesn't do me any good. Oh, well, it kind of does. Let me do it this way. I had done it a different way on my answer key, but let me do it this way. So still write I'm changing things up as I go. So I'm going to write this with the 1/2 out front, log base 2 of 8x. And remember that your thinking is you're going to get a multiplication problem for the log base 2 of 8x. You're going to get an addition problem because it's multiple. Let me try that whole thing again. Log base 2 of 8x. The argument is a multiplication problem. So you're going to change what's inside the pink parentheses to an addition problem. But don't forget to distribute the 1/2. So here, keep the log base 2 of 7. Keep writing that. And then 1/2 times log base 2 of 8 plus log base 2 of x. Sorry. But I also want you to notice that log base 2 of 8 can be simplified. So keep my log base 2 of 7 plus 1/2 times parentheses. Log base 2 of 8 is 3 plus log base 2 of x. And keep the log base 2 of 7. Now I'm going to distribute the 1/2. And that's my final answer. Now, before I go on to the next screen, just want you to kind of keep the work for this problem handy, because what we're going to do in a minute, the directions here say to expand. So these 12 problems that we just did together are expand problems. But then the next set of problems, the directions are going to say condense. And it's exactly backwards of what you did here. So for example, on the next page, I would give you this as the question and tell you to condense this. And then you would give me that as your answer, as your condensed answer. A single logarithm, no coefficient. So let's go ahead and take a look at the next page. So first of all, if you do have access to this document in Google Classroom or a hard copy of it, yes, I just heard a sound outside my door. It's really windy. I don't know if you can hear that, so I don't know if the wind blew my door open. I'm in my house. Anyway, let me back up a second. If you do have access to this document in hard copy, you'll see that at the bottom of this page it says more practice. And I'm actually not going to walk you through the more practice problems. I'm going to let you practice those on your own. So I'm going to walk you through these 12 problems here that say condense. Then I'm going to have you pause the video and practice some of the upcoming problems, and then I'll give you the answers to the rest of the packet at the end of the video. So this video is going to look short for me anyway, sorry. But it is actually going to assume that you are going to be spending time doing the practice problems. Please do that because the practice problems pull in some twists that you need to consider. So, like I said, the First four problems, well, let me back up a second. Like I said, that these problems start out expanded and you need to kind of pull them back in together. So this is going to feel more like simplifying. Some of them you'll be able to do in one step. And so the first four problems match the first four, I can't remember what colors I used. I think, yeah, I'm not sure. But the first four, I'm pretty sure it wasn't these colors, but you'll forgive me, I hope. Problems match those first four properties that are on the previous page so that you can kind of see how this all works. So if I give you, and first thing is you have to absolutely be sure that the bases of the logs are the same. If this said log base 8 of x plus log base 19 of y, then you're done. You can't do anything because the bases are different. But because the bases are the same, you've got logarithm of something plus logarithm of something. What you're going to do is take the two arguments and multiply them so that when you condense this, it's going to be log base 8 of xy. Done. Condensed. So the directions, make note, say to condense. In this one, and compare numbers 1 and 2, the only real difference between 1 and 2 is that in 13 has an addition, 14 has a subtraction. And so if it's log minus log, then when you condense this, your answer is going to take the two arguments and divide them. So this is going to be log base 3 of a fraction, a over b. And it's important that you keep in mind that if the b is after the subtraction sign, then the b is the denominator. Next, if you have a coefficient, so you've got a number multiplied by the logarithm, you're going to pull that number away from being a coefficient and make it an exponent. So this is going to be log base 6 of x to the 5th power. And then the fourth example here, if you have that minus sign out in front of the logarithm, that just makes the y a denominator. And so this is going to be log base 2 of, you don't have anything for the numerator, so you have to fill in a 1, so 1 over y. So what I want you to do real quick is to take a look at these first four problems. Look at the first four problems from the previous page and compare them and see that you understand that it's a backwards forwards process. That on the previous page we were going from completely condensed to completely expanded, and here we're given expanded problems and you're going to condense them. So the rest of the problems here then I'm going to walk through with you. Each of them has a twist beyond just that straightforward first step. So for example here, I see that I have a subtraction, but the thing that I want to notice first is that one of the terms, yes, you see two terms, let me just make sure. So I have this term. Remember, terms are separated. Mathematical terms are separated by a plus or a minus sign. And so this expression has two terms, but one of the terms has a coefficient. And so you need to take that coefficient and rewrite it as an exponent. And so this is really going to be log base 7 of a squared minus log base 7 of b. Because it's subtraction, your answer is going to have a logarithm with an argument that is a fraction. So this is going to be log base 7 of fraction a squared over b. And just remember that because the log of b comes after the minus sign, the b is in the denominator. So here again, you have a coefficient that is going to become an exponent. So the first step I'm going to do is rewrite this as log base 7 of m to the 1/2 power. But if it can be written as a radical, when you're condensing it, I actually want you to write the radical and not the fraction exponent. So log base 7 of the square root of m. So in number 19, I am going to immediately take the 2 and the 4 and make them exponents. So log base a of x squared plus log base a of y to the 4th. And because it's plus, the whole thing becomes log base a of x squared y to the 4th. And that's it, that's your answer. So be careful here. You've got the entire argument of a logarithm as a subtraction problem. It's not log minus log, so you can't touch anything to do with x minus 4. X minus 4 just stays x minus 4. So I'm going to start by looking at the 6 and the 3. Those are coefficients. Therefore, they become exponents. So I'll now write ln of x minus 4 to the 6th power. Just leave it like that. Don't try to distribute the 6. Don't do anything else with it. Don't pull apart the x minus 4. It's got to be exactly just x minus 4 to the 6th. Plus ln x to the 3rd. And now notice that you've got a logarithm plus a logarithm, and so now you're going to change this whole thing to a multiplication problem. This one gets a little ugly, but it gets the point across. And that's it. That's your answer. And that entire thing, the whole thing from the parentheses straight through to the x to the 3rd is the argument for the logarithm. So in this next problem, again, you should notice that you're adding log base 6 of something plus log base 6 of something, so that becomes a multiplication problem. Wow, I need a nap. 2x times 9y. But if you can simplify further, you have to. So for example, here, the whole thing, 2x times 9y, is the argument for the logarithm. Well, you can multiply the 2 times the 9 to simplify that further. So log base 6 of 18xy. And that'll be your final answer. Okay, and then number 22. Number 22 is interesting, and I want you to start by noticing that you've got 3 different terms here. That you have the log base 5 of x, that you have the log base 5 of y, and you've got the log base 5 of z. So that's 3 terms. And what I want you to do is notice that the log base 5 of x and the log base 5 of z both have a minus with the log. And so x and z are going to be in the denominator. But log base 5 of y has a plus before the log, so the y is going to go in the numerator. So my answer to this is going to be log base 5, big fraction, y in the numerator, x times z in the denominator. And what I want you to do here is just pause the video for a second and think about this. In number 23, again, you have a coefficient here that's going to become an exponent. You also have an argument that has an addition or subtraction problem inside parentheses. And so you can't pull apart the 3x plus 1. So when I rewrite the next step here, this is going to be log base 7 parentheses 3x plus 1. That will never be pulled apart to the 2/5 power. I'm not done yet. Make sure you understand the first step. But then remember that if you have a denominator in an exponent, that you need to rewrite that as a radical. So this is going to be log base 7 of the 5th root, and keep the parentheses, 3x plus 1 squared. The 5 in the denominator in the exponent becomes the 5 in the index of the radical, and the 2 in the numerator of the exponent stays an exponent that's a whole number exponent this time. And then in this last problem that we're going to do together, notice that it's not log minus log minus log, that it's a number minus log minus log. So you know you're going to end up with a 5 and an x in a denominator, but the 3 is not going to be a numerator. And what I want you to do, in fact, let me screenshot it and I'll bring it back. Hang on a second, it's going to magically appear. Magic. So look, I want you to take a look back at example 5 that we did a minute ago, and how we said that log base 3 of 27 simplifies to 3. So what we want to do is say, okay, we said that because 3 to the 3rd power is 27. And so remember, the other thing is that condense and expand are opposite functions from each other. They're inverse functions, or you're doing the forward and backwards kind of a thing. So here I'm giving you a whole number that doesn't have a logarithm on it, and you need to change it to something that is a logarithm, but this time, because the rest of the problem is base 4, you need to change this to something base 4. So your thinking is log base 4 of what is equal to 3, meaning 4 to the 3rd power equals what answer? And so in this case, that's going to be 64. So log base 4 of 64 minus, and then we'll deal with the rest of the problem and rewriting it and condensing it in just a second. But I'm going to hold on there for a second and just have you look at that and make sure you understand the forward and backward aspect of what I just did there. Now, the next thing I see is that I have a coefficient on one of the terms, and so that needs to be written as an exponent. So log base 4 of 64 minus log base 4 of 5. I'm just going to write the rest of it down. Minus log base 4 of x squared. And then notice that these two terms have a minus sign before the logarithm, and so the 5 and the x squared go in a denominator. But the 64 has a positive logarithm, and so this whole thing, the answer is going to be log base 4 of a big fraction. And I'm not going to pause the video for the clock. Log base 4 of big fraction 64 over 5x squared. Just take a minute again and make sure you understand that the way I changed and why I changed the 3 to log base 4 of 64. And then let me just give you a minute to look at the rest of the problems in that section before I have you do some practice on your own. So at this point, you're going to need to either look at the document that's on Google Classroom or find a copy of stuff, because I'm not going to show you the problems until I show you the answer key. So in front of you, I know that this is a long packet, but this concept is pretty important to practice. So I've done the first page and a half, but there's another 3.5 pages, and I'm going to just ask you to work on the rest of the packet, pause the video or shut the video off and come back to it in a little bit, and then I will next up just walk you through the answers to each page. So as you can see, here are the answers to practice numbers 25 through 30. For each of these screens that I show you, you're going to need to pause the video and check the answers, because I'm not going to sit and let the video sit for 5 minutes. So I've already given you more time here than you'll get on the next few screens, so just get your finger ready to pause the video. Oh, you can't maybe see that. Hang on a second. Sorry. Remember that you really need to look at the directions. Where it says expand, you're making the problem bigger with a bunch of logarithms being added or subtracted. Where it says condense, you're taking everything that's in multiple terms and making it just one term with one logarithm that doesn't have an x, or does not have a coefficient.